Okay, hi everyone. Like I was introduced, my name is Ifihanagbara Olusheye and Ifihanagbara Olusheye, but I go by Ifihan. And I will be taking you on a very short talk on what happens when two agents start talking. So basically, what the talk is on A2A. So how many people here know about AI or don't know about AI actually? Okay, great. Next question. How many of us know about generative AI or agentic AI or any form of AI? Okay, great. We're all in the same place. Perfect. So, like she said, I'm an AI engineer and a Google developer expert for AI. So, about me shortly, I go by Fion. I'm an engineer and I'm a researcher. I love AI. I basically use AI every day, and I'm more focused on the Gen and agentic AI, and I'm beginning to enjoy vibe coding because I want a soft life. So, what we're going to be looking at today, basically, we're going to be looking at the single and multi-agent AI. We'll be looking at the A2A protocol, we'll be looking at Google ADK, and what are the real world applications, and I'll walk you through a demo. So, the traditional approach that we're used to in before the whole A2A thing started was that we only had a single agent AI, right? And how it works is that you have one agent, one conversation, one task. So think of it like this. You want to book a flight or you want to maybe plan your trip. You ask the chatbot or you ask that agent that find me a flight, right? The agent finds you a flight. After he finds you a flight, look for an hotel for me, maybe nearby or somewhere. Then you go again and you say, find me a ride to the hotel, to wherever I want to go to. And you are the one basically coming, giving your prompt, getting the answer, going back. So you're the coordinator of everything. But then there's a problem because in the real world, I don't have to wait for you to think, to do like several things before you move forward to do something. So think of it like this. I expect my system to be smart to the point that I'm going for a trip. So as I'm going for a trip, you should know that I'm not going to sleep at the airport. Definitely. I'll need a ride. I'm not trekking because I don't know the place. So real world challenges are complex. Real world challenges require more than question, stop, answer, question, answer, stop kind of thing. So one agent can't be an expert at everything. No one here is an expert at everything. Well, for myself, I'm not an expert at everything, so I can't really say. Um, we have different things that will happen, right? You have the flight booking. When you want to book flights, they have tons of websites where you can book. There's several ways you can get cheap flights, all those kind of things. So you need an expert in that. You need an expert in finding hotels for you that would make sense, and you need experts that would know the local terrain of where you are going to give you a proper ride, right? So also the sequential processing is slow. What do I mean by that? Why do I have to wait for my flight before I start looking for the hotel? So it's like, how will I put it? I'm eating now. I'm eating and I'm eating and then I'm choking. So I have to wait until I finish eating before I can drink water. Like, I'll just die now. So I don't want to die. So that's how like the single agent works, right? Then you have to become the human in the system. You always have to put the stop. You always have to put um, the coordination, the task, and then it can become very burdensome. And at the end of the day, since there's no specialization, it tends to give you nonsense. And then everybody now be like, this AI is very, very dumb. It's not giving me, but you are the one giving it like so many things to do, but it's not an expert. So what do you expect? Like failure. So multi-agent systems. What would that happen if I have an agent that knows how to do A, an agent that knows how to do B, and all of them are talking to each other, and at the end of the day they come together and then they give me results? Does that make sense? Right? I know, right? Like, that's why I said soft life at the beginning. So now the multi-agent architecture is very simple. You have an agent or you have specific agents that are specialized in one thing. So you have an agent that does A, you have an agent that does B, you have an agent that does C. No one is doing the work of another person. So we're not going to be doing like amebo. What you ask me to do is what I'll be doing. Do you ask me to do editing? I'm just going to be doing editing and editing alone. Do you ask me to do generation? I'm just going to do generation and generation alone. So all of them have their own expertise, whatever the English is. They work in parallel, right? They don't have to wait for, they don't have to always wait for you to come in and for you to tell them what to do. They all can communicate with each other and they give you the result. So basically how it works is you have the orchestrator agent and you have the agents that will be working, and then at the end of the day you have you at the end. So you are here, you have the agents here, and you have you at the end. Does it make sense? If it's not making sense, someone can just raise their hand and I'm like, oh okay, something. So now we're talking about all of this, and then some people might be wondering, MCP. Did anyone think about that, like, as I was talking? Okay, great. See a hand. We need person we're on the same wavelength. So, some people wondering, like, why is MCP in all of this? I thought Anthropic brought out this protocol to, do things for me, to make life easier than just doing the whole generative AI. And I can talk to external sources. But then, it's kind of different, right? MCPs are not single agent systems. They are most like tool integrations. They don't have the agentic architecture. So I'm kind of picking my words. I don't want to be misquoted because this is a very tricky thing when discussing. So MCP is basically AI and tool integration. You carry your MCP maybe to your calculator, to your database, to wherever you want it, and it helps to connect your AI to external tools, standardizing the access of your data sources, and that's it. So it's like a tool, it's like an AI toolkit, not the whole A2A thing. Yeah. So now this is how it works. This is how it looks like. You have your single agent that is the user, your AI agent does everything, and you have your results. And on this multi-agent, you have the user, you have the coordinator or orchestrator agent, you have your agents in 3 different places, and you have your result. They all come together when they are done, and they give you your result at the end. So, but how do agents talk to each other? You might be wondering. We have agents that do different things, but challenges comes. If you are using different AI models, they have different capabilities, different formats. Maybe one is receiving in this particular kind of response, another one is receiving this particular kind of response. They have different platforms. How can we provide a standard language for this our agents to communicate? All right, all of us here, we are from different backgrounds, right? But we all understand ourselves because we all speak English. So that's the kind of thing that we're looking at here. So how can we, bring that kind of system to the AI world? So that's where the A2A protocol comes in, and it's called the agent to agent. So the A2A protocol was introduced by Google, and it is a standardized framework for AI agents to discover each other's capabilities, negotiate task execution, exchange structured information, and coordinate complex workflows amongst each other. So you think of it like HTTP for AI agents. So how does it work? You have some concept on how it works. You have the agent discovery. So basically this one is like, who can help with task X? And then this agent is like, oh yeah, I can do this. And then they come, you do it, and then they pass it to the next agent that can, oh, I can do this. And then they just keep on discovering themselves. Then the capability advertisement of, oh, I can handle maybe editing, I can handle image processing, I can handle this, and then you start delegating the task. So the agents from A to B to C, they start delegating tasks to each other, and they follow a standard schema of communication, and they aggregate the results, which at the end of the day gets to you. So it's basically something like this. Agent A, I need to analyze customer feedback. Then agent A will discover agent B, then gives agent B. Agent B is like, yes, I can do this. Then they go back and forth, back and forth, back and forth. And then at the end of the day, you have your result. So the message format is something like this, that you have the sender, you have the recipient, you have task. Basically, you are the one that would determine how your format should look like. Then, what are the real-world applications where MCM, A2A comes to shine? Almost said MCP. So, you have the customer service where you have the router that goes to the billing agent, to the technical agent, to the returns agent. You have your content creation, you have data analysis, and you have software development. I think most of us, I don't want to not generalize, but a couple of us here that do write code or and look at these examples and how they work for you. So now after we have the protocol, right, how can we use this protocol in our system? So the protocol sounds super cool, it sounds like it's solving a lot of problems. How can we use it? So Google said, oh, after we give you this protocol, right, let's give you a means to use it. So we have the Agent Development Kit, ADK. So it's a Python library. Well, you have for Java and you have in 3 languages, Java, Python, and I think Go. But basically, you have a Python library for building multi-agent systems. Sorry by the way I picked Python. I write Python like, it's only Python I've been writing all my life, so I had to pick Python. So what are the key features? The key features include A2A protocol support, agent orchestration tools, pre-built agent templates, state management, and memory. So why should you use it? You are focusing on your agent's logic, not the infrastructure. You don't have to start setting up the protocol yourself. You don't have to start setting up a couple of things yourself. You are only focused on the logic and how to make your system very okay, if that's the right word. So basically, this is how the ADK library looks like, right? You import from Google ADK, you import your agent, and you import your agent runtime. So this is a researcher agent that is being implemented here. You give it a name, you give it a description, and you write your logic, and you return what it should return, and you register your agent, and you pass it into your main. So they can all, they know themselves by names, and they can all discover themselves. So, so now let's build something, right? I'm not going to be building here. I've taken it and I've done sleepless nights. So I'm just going to walk you through a demo of how you would build something very simple with Google ADK. So what we're building is that we're building an intelligent technical blogging assistant that basically streams, does the whole workflow for you, from your blogging workflow to publication. That's social media and whatever you have. So what are the tools we'll be using? We'll be using Python, and we'll be using the key libraries. Google Gen AI. Google Gen AI is for using this Gemini and the likes from Google. You have Google ADK, and then you have your Python.env, to keep your keys so that someone does not steal it and put you inside depth. So this is how it looks like. I did not design this. I took it from the ADK samples repository. So we have our interactive blogger agents here, and we have a couple of agents. You have the blog writer, the planner, the editor, the social media writer, save blog post to file, analyze code base, and each of them are doing different things, right? So you can see the functions of each of those agents. So the blog writer does a validation checker and he uses Google search, and he goes to the blog planner that does the validation checker kind of thing. So this is a simple system design for the blog assistants that we are building. And we start with the orchestrator. If you remember from previous slides, I mentioned you have the orchestrator, right, that manages the entire workflow or does the whole agent discovery for you. So you have that, then you have the specialized sub-agent that would be using. That's like the ones that we saw here on the left-hand side. And then you have your tools that you use. So also, I forgot to mention, when you're working with A2A, you have agents and you have tools. The agents use the tools, so you can always describe your tools that the agents should use. So after you have your sub-agents, you also have your tools. And how does it work, right? You first analyze the context from the user provided directory, maybe the document, or you have the person gives you a code base. And then you have the plan. The plan uses the robust blog planner agent to create a structured outline using Google search. If you remember, you saw that Google search thing right at the top. So then it moves to refining, it moves to visuals where needed, and then it writes for you, it edits for you, so you don't have to do the editing, and then it creates promotional content for your Twitter and LinkedIn, and it exports it for you. So that's basically how that Blogger agent works. So you can see I do not have to say, oh, create a draft for me. After I create the draft, and I'll say, okay, look through my draft, remove every blunder, English blunder, or make it standard. And I'll say, oh, okay, after I are done, now create caption for my Twitter and LinkedIn and something. He already knows what to do. Everything has been outlined here. So from the creation, it takes it to the agent that will do the editing. It takes it to the agent that does the refining and whatever, the editing, and takes it to the agent that creates the blog post for you, and it takes it to the agent that exports for you. So you are just there, you've given it your prompts, and then it just works. So the orchestrator agent serves as the primary infrastructure, delegates tasks, and what do you use for this? You use the agent class from the Google ADK, and because it has it's a class, so it has several behaviors inside that you can use for detailed instruction and list the sub-agents that is inside. So this is basically how the orchestra. I'm going to show you the code. So sorry that it's quite small. I don't think it's visible. But basically, this is how the orchestrator agent looks like, and it manages the 8-step workflow that we have. Then each sub-agent will now have their own rule. And for example, I only put these. This is the one for the block planner. This is the block planner agent that is written here, and we gave each of them different tasks to do. So this particular agent, the sub-agent that is here, is using Google search to create well-structured blog outlines for me. Then it moves to the robust blog writer, then it moves to the blog editor, and it moves to the social media writer. So how do we ensure reliability? You might be thinking, because what if one agent goes down or one agent misbehaves along the way? You have the loop agent pattern that comes with the development kit that helps you to validate and to help you check if it should continue or escalate to you. So if what you are doing is valid, it continues. And if it is invalid, it retries and it would escalate to you at the end of the day. So this makes it to be self-healing in a way that you can get quality outputs without trying a lot of times. Even on your first try, you can get a quality output. So how do they share information together? They have the shared session states where they have access to all the agent. Where they have access to all the content that is happening. All the agents have access to that in that particular session, and they just share from that pool. and they have this shared context. So that's basically what happens, and I'm just going to show you what it looks like. So the resources, I uploaded it to that particular link. You can check my repo for it. In my free time, I should actually work on more A2A projects. I've been doing more of Gen AI and Agentic. You can get more samples. I stole this demo from, I'm using the word stole, so that nobody comes and say, oh, she did demo, she took it from this. I'm casting myself already. So it's from this place. You have these ADK samples by Google, and I took it. Yeah, I took it from this place, and yeah, you can check it there. Then you have the ADK docs, where you can read on what the ADK is, and you have the A2A protocol. So if you are interested in building A2A, you can building on the protocol, you can build this. And yeah, a question that someone might throw at me is, does this bring decentralization to agents? I don't know. I can't answer that question because it's a very tricky question, and some people are saying yes, some people are saying no. So I'm not entirely sure if it's going to bring decentralization to agents. And yeah, if you have any questions, I should be around. And thank you. Enjoy the rest of the event.